Welcome everybody. So in this today's video we will see the topic p block elements. So the aim for today's video will be to see what are p block elements, the groups which come under p block elements. We will go in depth with group 13 elements. We will see the chemical and physical properties of group 13 and the variation in trends in chemical and physical properties. And we will also see some important compounds of boron. So now we will see the boron family, that is group 13 elements. So we know the elements whose last electron enters in p subshell are called p block elements. Now we will see the group 13. Group 13, the boron family shows high oxidation state as well as low oxidation state. The high oxidation state will be +3 and the lower oxidation state is +1. The general electronic configuration of group 13 elements is NS2 and P1, that is total 3 electrons. So the elements which come under group 13 elements are boron, aluminium, gallium, indium and thallium. The atomic number of all these are: boron is 5, aluminium is 13, gallium is 31, indium is 49 and thallium is 81. The boron family is called heterogeneous family. This is because there is no regular trend in their properties such as chemical properties and physical properties. In these elements, boron is a non-metal. All these elements are metals. Now we will see the physical properties of boron family. First we have atomic size. As we know, as we go down the group, the atomic size increases. But in this case, gallium comes first, then aluminium. This is because due to the poor shielding effect of 3d orbitals. As we know that d orbitals have poor shielding effect than s orbitals. Second, we have electronegativity. As we can see here, these are the values of electronegativity. First, it is decreasing. From 2 it is coming to 1.5 and suddenly it goes on increasing order. This is also due to the poor shielding effect of 3d orbital, 4d orbitals and due to lengthened contraction. Next, we have ionization enthalpy or energy. Ionization energy. As we can see here, there is irregular trend. This is also due to the lengthened contraction. As we know, atomic size has inverse relation with ionization enthalpy. As we can see here, there is an irregular trend in these elements. So now we will see some chemical properties of boron family. First, reactivity towards air, that is oxygen. Any element of group 13 elements plus oxygen give rise to that element E2O3. For example, we have B2O3. Boron plus oxygen gives us B2O3 and it is acidic in nature. It means it is an acidic oxide. For others like aluminium, gallium, they form amphoteric oxide. And for indium and thallium, they form basic oxide. Second, we have reactivity towards acids. As we can see here, boron plus any acid, there is no reaction, there is no effect, means there is no reaction or product form. For others like aluminium, for example, we have aluminium plus HCl, which gives rise to AlCl3 plus hydrogen gas is released. Third, we have reactivity towards nitrogen. Any group 13 element plus nitrogen give rise to form En. For example, we have aluminium plus nitrogen gas gives us Aln. So next reaction we have reactivity towards halogens. For example, we take aluminium, which is a group 13 element, and chlorine. We know that group 17 elements are halogens. So when aluminium reacts with chlorine, it forms AlCl3, which is unstable. So to achieve this stability, it forms a dimer. It achieves the stability by forming a dimer. So before we go into this dimer, we will see why it is not stable. As we know, aluminium will have 3 electrons in its valence electrons. Chlorine will have 7 electrons. And in this compound, we can see that aluminium will have only 6 electrons, which is less than the noble gas configuration. So to achieve the stability, it will form a dimer. First, it is this compound AlCl3 is trigonoplanar. That is, it will have the structure like this. 3 chlorine bonded by covalent bond, but it is not stable. So to achieve this stability, it will form a dimer. So 2AlCl3 will form Al2Cl6. So by forming a dimer, it is stable. This aluminium has 3 covalently bonded chlorine, and this aluminium will also have 3. But by forming a dimer, this aluminium will have 4, this also aluminium will have 4. So they will be stable. For extra information, I will tell you that the angle of this chlorine is 101 degree. The terminal bond is 206 picometer. The bridging bond is 221 picometer, and the angle of aluminium is 180 degree. Like reactivity with oxygen, reactivity with nitrogen, reactivity with halogen, there are many such types like reactivity with alkalis, reactivity with dilute acid, etc. So now we will see some important compounds of boron. That is, first we have borax. The formula of borax is Na2B4O7.10H2O, 10 water molecules. So we can also write it as Na, the whole bracket, B4O5 bracket OH4 multiplied by 8 water molecules. So the structure of borax is somewhat like this. And also one important thing I want to tell you all that there are many uses of aluminium and boron, and as well as their compounds that we will see in the report, and few more reactivity towards some metals and elements are there that we also will see in the report. So in the structure of borax, we can see that the oxidation state of boron is +3. We can also count the types of bond like BOB bonds. Total number of BOB bonds, that is 1, 2, 3, 4, 5. So we have total 5 BOB bonds. Like that we can also count OB bonds. Total OB bonds, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have total 14 OB bonds. Next important compound of boron is boric acid, H3BO3. It is also called orthoboric acid. So we can see the structure here. Boron is bonded with 3 OH, 1, 2, 3. So the hybridization of boron is sp2. How we find the hybridization? We see the lone pair and bond pairs. We add them both and we get the steric number. So the steric number of boron is, we can see that there are only 3 bond pairs. So total we get 3 bond pairs. So the steric number is 3. So the hybridization is sp2. In this structure, we can see that it is a planar molecule. Why it is planar molecules? Because it has hydrogen bonding in between hydrogen. Similarly, there are more such cases of boron family. There are many important compounds of boron. Such many types are included in the report. Till now, in this video, we saw many physical properties, chemical properties, their reaction towards air, water, acid, etc. But there are many more reactions and physical properties and chemical properties, such as the melting point is there, boiling point, the density of the elements, density. Also we have the anomalous behavior of boron. All the things which are remaining are added in the report, plus the information about group 14 elements, that is the carbon family, is also added in the report. The chemical properties, physical properties, catenation, all the reactions are added in that report. So this is all for today. Thank you for watching this video.